K8BYP working on the HP8660 and the topic of the mystery foam. When I took the cover off A13, A14 and looked at the gasket, see a couple of darkened streaks that weren't on the other shields, on the other gaskets. No clear sign of what that is. I redid these boards over to here, took the A1617 off, and inside were tape strips and foam. You can see a little bit of the glue left over, and I've marked with ink pen the extents of the foam. I used an ohm meter and checked the foam. It's not conductive foam. This wasn't really the day of doing that. This was more the day of metal gaskets and metal shields. This was the 1980s. This was not the era of RF absorbing foam and assemblies like we have now. Notice something interesting. I'm going to get the microphone right in close to each of these boards that had covers that had foam or evidence of foam, and I'm going to flip them with my finger and listen to them. These are the two that I've taken out and reconditioned. That's A13. That's A14. Notice the two pots. Notice the inductor, clamshell, sort of a toroid. And over here on A16, A17, here are the persistence. That's A16. That's A17. And see the card. Okay, looking on the Hewlett-Packard Agilent forum, under the topic 8660C craziness, we see a bunch of uneducated persons wildly guessing at what causes microphonics and need for the foam tape. The lead comment rephrases a meme of something about currents on shields. Where have we ever heard that before? A false meme about mystery problems being caused by currents on shields. Well, we hear it in amateur radio in this BS about mythical currents on transmission line shields. I have a video debunking that. To show utter lack of education, a total lack of understanding of any kind of physics education. If you look that post up, you'll see the topic is microphonics, which is mechanical, but trying to blame it on mystery currents. This is simply making crap up. But notice what these boards have in common. Out here on the far edge, away from the socket, two pots. This pot core, I think it's called, on that board. Same on that board. Two of those out there. Notice the pot core isn't glued. And if that's an oscillator coil, vibrations in that core will absolutely cause a change in inductance and a change in frequency. What's critical about these two-piece cores is where they fit together. They have to be in magnetic contact and physical contact. Separate them just 1/1000th of an inch, and the permeability changes big time. And these also have large potentiometers, which, if you see my video on pots, that's a spring brass or bronze wiper pressing against a resistive trace, quite possibly subject to vibrations. But notice the boards that I took out and put back in. Those are stable. The ones I haven't done, that one vibrates badly, suggesting a resonance. So I'll dig into these and see why. It can't be anything conductive because there's nothing to conduct here. The foam is pushing into these component leads here, but not on this board, so it can't be electrically conductive. So what is being vibrated is not the main question. The main question is what's causing the vibration. This unit was what, 20 or 25,000 bucks new? We don't go pounding on it. There are two sources of vibration in this unit, and that's the big honking cooling fan back here, which will set up horrific vibrations, and the thing that's hiding from our view, the 60 cycle transformer vibrating in 8 milliseconds. And those two things will set up terrible vibrations through this chassis. And my power supply redesign is going to eliminate both of those. This is a 75-pound piece of rack mount equipment. It's not bench top, it's not portable. There's really no reason for it to be set in a place with vibration. Using it doesn't cause any particular vibration. Pushing the control panel's not in there, but the keys, the push button keys on the control head are not mechanically coupled, they're magnetically. So there's essentially no vibration from that. So, pardon me, there's a deal with the foam. So what I'm going to do is it wouldn't be proper to put something like caulking or glue and fix the board rigidly to this chassis here, because that would tend to couple more vibration. So what they did was probably the right thing. They coupled it to the cover. So I will probably do that again, but it's likely that the obvious change in the response mechanically of that board after I redid the board means something. But that is extremely sensitive. And it's obviously got something to do with the socket. So PWBs did it.